So I'm going to say something that may upset a lot of computer science students, graduates, lecturers, and probably some parents too. Your computer science degree is not a job readiness program, and the sooner you understand this, the better your chances of actually becoming and building a successful career in tech. I'm not saying that your degree is useless. I'm not saying that you wasted 3 years of your life. No, and I'm definitely not saying that you should be dropping out of your university after watching some motivational video on TikTok. What I'm saying is going to be much simpler. It's that you were sold on the wrong expectation. Most people enter university believing that there is a clear transaction. You study hard, you pass your subjects, and you complete your degree. Then the job market rewards you later on with a good career. That was the deal. At least that was the deal that everyone around you made it sound like. Your parents told you to study hard. Your teachers told you to get good grades. Society told you that computer science was one of the greatest and safest degrees that you could be doing because technology was the future. Then you graduate and you send out 100 job applications, and suddenly you realize that employers want things that nobody properly trained you to do. They want the experience, they want the real projects, they want you to understand Git and GitHub, they want you to know how to work with other developers, to read an existing code base, to debug something that you did not build, to deploy an application. They want you to communicate clearly, they want you to understand what the business is trying to achieve, and they want you to learn how to use AI without completely depending on it. And you're sitting here thinking, like, I spent 4 years doing my degree for this, how am I not able to qualify for an entry-level job? What's going on? 4 years is a long time, come on, and a lot of money. I understand why graduates may feel cheated sometimes, but the truth is a computer science degree was never really designed to make completely job ready. It was designed to teach you computer science. And those are not the same things. I know this because I didn't come from a traditional computer science background. I did finance for my degree, and my original path was supposed to be very different. I was exposed to finance, venture capital, startups, and businesses. And the more I saw how the world was changing, the more obvious it became to me that technology was going to eat everything up, regardless if it's software or AI. The biggest companies were technology companies. The fastest growing startups were built around technology. A huge percentage of the remote and high upside career opportunities that I saw were connected to technology. I realized that whether I wanted to start a company or to work remotely or to build products or create more options for myself in this world, understanding technology would certainly give me some leverage in life. So after university, I quickly tried to teach myself how to code. It was really hard. It was not the inspirational cinematic kind of hard where you struggle for 2 weeks, drink some coffee, and suddenly now you're a software engineer. No, it was confusing. It was tough. I jumped between tutorials. You learn one tool, then you discover people online are bashing on that tool and telling you that it's outdated and you should do something else. Then you go on to JavaScript, and then you go on to Vue, and Vue isn't good, and you go to React, and then the backend tools are important, databases and APIs. So I built applications, I broke applications, I stared at errors that completely made no sense. I'm ashamed to admit it, but I have copied a lot of code without understanding what was going on. And then I had to go back and actually understand it to understand when everything started to break. There was no lecturers or mentors telling me exactly what to do next. No neat and pretty semester schedule. No exam where I could memorize the answer to and write it down and move on. So for me, it was simple. The product either worked or it did not work. The user either understood it or they did it. The product either solved a problem and we got paid, or it didn't. The process taught me something simple. Learning about software and building software are related, but they are not identical. Learning about software is a subset of building an amazing software product. You can know a lot about programming without being able to build a useful product. You can build something that looks impressive while having real serious gaps in your fundamentals. The strongest people need to have both. They need knowledge and execution, theory and practice, understanding and proof. And this eventually became one of the reasons why I started Sigma School. Over the years, I've spoken to and have mentored hundreds of students, or just simply people trying to break into tech. Some had computer science degrees, many of them had. Some came from accounting, we had people who came from medicine, from marketing, from engineering, from design, and completely unrelated industries. Some never went to university. So we've helped over 100 people break into tech today and successfully land jobs. And we have worked with employers and hiring partners that actually look for talent. And after seeing this process repeatedly, cohort by cohort, I can tell you something that many students don't want to hear. The degree is not usually the biggest difference between the person who gets hired and the person who remains stuck. The biggest difference is proof. Can you prove that you're able to do the work? Not prove that you attended a class, not prove that you have passed an exam, not prove that you understand some definition. Can you prove that when someone gives you a messy problem, you can turn it into a working result? And this is where many graduates will end up struggling. A student might understand database normalization in theory, but never design a database for a real product. They might know the definition of API, but have never integrated one into an application that real users depend on. They might understand OOP, object-oriented programming, but freeze when they enter an unfamiliar code base with terrible variable names and missing documentation. They might get an A for software engineering subject, but have never deployed something, never received user complaints, never fixed production bugs, or worked under a strict deadline. That doesn't mean you're stupid. It just means that they were trained for a different test. Universities test whether you understand an academic curriculum. Employers test whether whether you can create value inside a business. These tests overlap, but they are not the same. And this is also why sometimes employers seem unreasonable. You see an entry-level job asking for experience and you think, how am I supposed to get experience where nobody is willing to give me a job in the first place? And that frustration is valid because some job descriptions that I've seen today are completely ridiculous. Some companies want a junior employee, pay a junior salary, but expect a mid-level output. But from the employer's perspective, I gotta say that hiring is expensive and it's risky. I'm a business owner myself. When I hire someone, I'm not paying to reward them for how hard they study. I don't really care, right? I'm hiring them because the business has a problem and I'm hoping they're here to solve it. That might sound harsh to some of you, right? But that is just how every business works. A company does not pay you based on how difficult your journey was. It pays you based on the value that it believes you can bring and you can create. You can disagree with what I said or just be angry about it. That does nothing to your employability. Being angry does not change the rules of the game. Understanding the rules gives you a better chance at winning. And this is where I think that universities and students both need to be honest. Universities should stop marketing degrees as though graduation automatically leads to employment, because it doesn't. And students should not treat university as though it's a must-do and the final stage of their education and development. Your degree is only one part of your growth, one part of your development, one part of your education in your life. It cannot be the entire thing. There's a very famous quote by Mark Twain, who is an author and a writer and also a lecturer back in the 1900s. It says this: do not let schooling affect your education. So what he was trying to essentially say was that institutional learning often creates a lot of conformity, while true education requires a lot of curiosity. Twain also emphasizes on the rigid curriculum of schools and the real-world wisdom gained through experience. A degree definitely provides you the credentials, but life provides you the deep understanding necessary to navigate this world. To be fair, universities also have an almost impossible job. Technology changes extremely quickly. A company can change its technology stack in a few months. An industry can completely change its hiring requirements in a year, but a university curriculum could take years to develop, to approve, to implement, and to update. By the time a new subject is introduced, the tool that's being taught may already well be changing. Universities are naturally better at teaching things that remain useful for a long time, like algorithms, data structures, computer architecture, operating systems, networks, mathematical thinking, the deeper principles behind computing, things that never really changes. These things absolutely matter. They make you a much more stronger engineer over the long term. But universities will always struggle to keep up with every framework, tool, hiring trends. And that is not necessarily a failure. It just means that you cannot outsource your entire preparation to university. And now AI arrived, and this gap is become even more obvious than ever. Previously, a junior developer could create value by handling the simpler coding task. They could write basic components, build straightforward pages, or fix small bugs. Basically, they could slowly learn while taking lower complexity work from senior engineers. However, AI is here, and AI can do a surprising amount of that work. That does not mean that software engineering is dead. It means that the definition of an entry-level software engineer is changing. The market no longer needs as many people whose only role is to remember syntax. AI remembers syntax than any of you. It generates codes faster than any of you. It can explain unfamiliar libraries in seconds. It does not get tired of writing repetitive functions, so competing with AI based on typing speed will be an incredibly stupid career decision. But AI still produces wrong answers. It creates insecure code, it misunderstands requirements, it confidently reinvents things wrongly, it solves the wrong problem gracefully. That means that the valuable engineer is no longer just the person who's able to code. It is the person who's able to think clear enough to direct the AI, review its output, to catch the mistakes, to understand the user, and take responsibility for the final result. The bar of generating code has gone down. The bar for judgment has gone up, way up. And this is one of the biggest changes that we've had to make at Sigma School. It was a lot. I don't believe that students should learn as though AI don't exist. That would be like training accountants without spreadsheets because you want them to understand arithmetic. But yes, the fundamentals do matter, and students need to learn how to think independently. But pretending that modern tools do not exist is also not the right way for a career-focused education plan. At the same time, allowing students to just blindly rely on AI and blindly copying everything is also equally as useless. A student can create a beautiful platform, a beautiful application using AI without understanding a single line of code. And the moment something breaks, they become completely helpless. And this is why the question cannot simply be, did you use AI? The better questions are, can you explain what was built? Can you identify what was wrong? Can you modify it? Can you defend your decisions to making this whatever design decisions you make? Can you debug it when the obvious solution fails? And that is closer to how real work happens. When you are working inside a company, nobody gives you marks because your code looks beautiful. They care whether it works, whether it is secure, whether another developer can maintain it, whether customers can use it. They care whether the feature increases revenue, reduces costs, or improves the product. And this is the part of software education that most people miss. Coding is not the job. Solving problems through software is the job. Code is one of those tools, AI is one of those tools, communication is a tool, product thinking is a tool, understanding the business Job-Readiness is a tool. The person who combines all these tools together will become the most valuable in the market. The person who only knows how to answer exam questions becomes way easier to overlook today. So what should you do if you're currently studying computer science? First of all, do not panic. Your degree still gave you an advantage. You are being exposed to concepts that many self-taught developers struggle to learn later. But stop believing that completing your assignments is enough. Treat university as the foundation, not the finished product. When you learn databases, build something that requires a real database. When you learn web development, deploy something that strangers can actually use. When you learn algorithms, understand where they matter in real systems instead of only memorizing interview patterns. When you learn software engineering, collaborate with someone else and experience how difficult it is to work inside code that you did not write. Build projects that solve problems that you actually care about, not another calculator app, not another basic to-do list app that you copy step by step from YouTube. Build something messy enough that you are forced to make decisions. Then launch it. Let people criticize it. Watch users misunderstand it. Then fix it and improve it. That whole experience will teach you things that no multiple choice examination can teach. You should also learn how to explain your work. A surprisingly large number of technically capable people struggle to communicate. They cannot explain why they chose a particular approach. They cannot describe the problem that they solved. They cannot tell an interviewer what went wrong and how they fixed it. They will hide behind technical words instead of communicating clearly. I have faced this so many times. In a real company, your ability to communicate affects whether people trust you with bigger responsibilities. And please stop collecting certificates as a substitute for building. Please. I see people finishing courses after courses, right? They did a HTML course, then a JavaScript certificate, a React, Python certificate, AI certificate, cloud certificate. Please just stop. That makes you feel productive because you're constantly learning, and that's good. But if you're learning and you still cannot build something yourself without following someone else's instruction, that is not a knowledge pattern anymore. That is an avoidance problem. At some point, you need to stop preparing to build and actually start building. I know this because I've experienced myself. There was always another course to take. There was another framework I could learn. There was another tutorial that promised that to make everything better. But honestly, the biggest growth that came to me was when I started to throw all of them aside and tried to create something myself from scratch that was beyond my ability, because that's exactly when the gaps become visible and that makes learning become so much more real. I also want employers to take some responsibility here. Companies complain that graduates are not job ready, but many companies are unwilling to train anyone. They want universities to produce candidates who already understand their exact technology stack, internal processes, and business model, and that's just simply unrealistic. The junior employee is supposed to have some gaps in their knowledge. Entry-level talent needs structure, they need feedback and opportunities to make smaller mistakes before taking on larger responsibilities. We cannot complain about a talent shortage while refusing to develop and invest in talents. But graduates cannot control whether employers behave responsibly. You can only control yourself and how prepared you are when an opportunity arises. And this is why I would never tell a young person, just go and get your degree and everything's gonna be fine. That advice is completely outdated. I wouldn't tell them to get a degree. I will only tell them to do it if it aligns with their goals. Ultimately, you gotta learn the fundamentals deeply with or without a degree. Build while studying. Use AI, but don't let it replace your thinking. Get comfortable being confused. Work with other people. Create proof. Understand business. Learn to communicate. Basically, you gotta try and become as useful as possible to real businesses and real people, because your degree may help you enter the room. Yes, but once you're inside of the room, nobody cares about your degree anymore. They don't care about how you enter. They care whether or not you're able to help them and whether or not you're able to contribute. The biggest lie that we told an entire generation was not that a computer science degree had value. It does. The lie was that the degree alone would be enough for a job. It isn't. And to be honest, it probably never was.